don't know what it does. All right, recording on the computer. We're recording. All right, so today we're going to continue down the path of synthesis definitions. How do we make them? How do we make sounds? Hopefully what we'll be able to do is to define synthesis definitions and then use our array knowledge to be able to make these instruments have an interesting score. So here's the things we'll be working with today. I would love to be able to print these. I don't think we have paper. So you'll just have to download these on your computer and deal with that. So if you go to Folio, you're going to find these synthesis definitions in the Folio. And I recommend you go ahead and download those. All right, so while you're doing that, I'm going to launch Super Collider. All right, and while you're doing that, I will point out that the homework for this week is to get caught up. So if you have been lagging behind, we have already covered, I believe, 5 of the YouTube tutorials of Eli Fieldsteel. They are concise and relatively brief. So if you haven't done those, you will need to binge watch Super Collider tutorials, 5 of them. It's not so bad. And when you watch those, it's important that you put those practices into practice by doing some of the stuff. You won't learn this by osmosis. You have to do it. Additionally, there's this getting started tutorial series, which I assigned before. And I did give a link to it online, but it's within Super Collider. So anytime you want, you can hit up this thing here. And I think we went through the first 6. Which would explain some things to you. And of course, there's other things like SynthDefs and synths we're covering right now. There's plenty of help to be had from other sources if you feel like you need more help. So here's the other tutorials. Not as useful, I would say. Although this Mark Polishuk tutorial is good. That's another one that's, same sort of stuff. Obviously, the one I've assigned the most reading from is the one that's linked online, A Gentle Introduction to Super Collider by Bruno Ruviaro. And I highly recommend that one. We have done pages 1 through 15 and 41 through 61 was assigned on Tuesday. That will help you out. And throughout that book, there are more things that will help you. In that book, he covers patterns fairly early on, and we're not going to do that early on. So just skip that chapter. Okay, so let's get down to business. Last time we coded up. Oh my God. Last time I can do it. There we go. Yes. Yes.
So in the Folio for week 3, day 1.
Yes, day 2.
You want us to turn in the SynthDefs created from that flow chart. You said like the one that we did in class.
In a Dropbox.
Yeah, but the one that's linked on Folio is one for array modulation. Do you want to do that instead?
That's the one I want you to do.
Okay, cool.
Yeah, sorry if that wasn't clear. That's the one I want you to turn in. We have not done that. It's for ring modulation, which is 2 oscillators multiplying together. Should be easy. The hard part, of course, is formatting everything correctly. All right, so I think I'm going to download this so that it's not here. And there we go. I wonder if in Super Collider, I could just drag this in. Nope. All right. Yeah. Let's keep those right there to the side somehow. Uh, there we go. All right. So last time we coded up the following synthesis definition, right? Having to do this on the computer, so it's a little difficult. But we had an output that was fed a multiplier. Let's just say times 1, 0.1. That was fed a sine oscillator with some arguments and stuff. That was fed an envelope. Well, that's not exactly true. So basically this, right? A sine oscillator and had an envelope attached to it multiplied by 0.1 and through an output. So let's just pretend that there's nothing else to this but just a sine oscillator that goes to an output. That's what we're going to try to code up here. So watch along with me and help me out. How do I start making a synthesis definition? Right, so we have to remember just pure memory, like you're memorizing Abraham Lincoln's Gettysburg Address. That SynthDef is what we use. Now, once we know that, it's easy to get help on this if you can't remember, right? Oftentimes, because I've done this for a long time, it's just easy for me to start going. And there's many things about it that will help me to just go. But maybe the best idea is just to go to the help file. And, you might get frustrated that there's so much reading, that you're like, I just want to know how to use the thing. Oftentimes you go all the way to the bottom of the help file. You'll find how it's actually used, if that's of interest to you. And of course, we have our class methods. What's a class method, Tommy?
It's a method that it, like the class that you can tell it.
Okay.
But it refers to like methods related to like the entire class of like definitions, not like one specific definition that you can.
Right. So this talks to the blueprint, and basically all the methods will be ways to create instances of the object. So that's important. What's an instance of an object, Josh? As opposed to the blueprint.
It's I guess it's just kind of a point in time how that object is.
Right. So to pull this back to Plato has the ideal of a chair, right? So Plato says that there's this ideal of a chair that when we bring it into existence is no longer the ideal because it's a real chair that you sit in. The ideal chair you don't sit in, it's just an ideal. Right. So that's another way to think about this, is that there's an idea of something, an idea of a synthesis definition. There's a blueprint for one. But when you make one, that's different. That's one you can actually use. Right. So back to the car again, we have a car factory that has a blueprint for a car. You cannot drive the blueprint. You can only make cars from the blueprint. And the blueprint may have different methods which allow us to make different cars. Anyway, for this one, let's look at all the class methods there are. There is wrap. That's an interesting one. Write once. Look at all that. So there's some interesting stuff. The one we're going to use is .new. And you will often see it in Super Collider that people just skip the .new. And it just assumes you're making a new one, but let's not skip it. Hey, DeAndre. And when I hit the enclosure there, right, up pops all these keywords. I highly recommend you use the keywords. I would even recommend that you format it in the same way I do. So now I hit return, keywords stay there. And if you hit tab, the keyword pops up. The keyword is the argument that the object wants, right? So it's like, I need to make a car with how many tires? 3, 4, 12? So here it wants a name. And if I'm looking at the help file, right, I can look right over here. It says name, it says a string or symbol. right? So I have to know how to make those, and it tells me, like in quotes or with the backslash. This name will be used to refer to the SynthDef when creating a synth based upon it and should be unique. All right, so I'll put in unique. It's like a joke. All right, and there are a list of these. So it even shows you right here, like, well, there's the comma. You got to separate things with a comma. So it showed me all of that. I go to the next line and I hit tab, right? And I can tab through all of the different keywords, but I really just want the next one, which is UGen graph func. And so it's, what does it say? It says an instance of function specifying how the defs UGens are connected. Well, we talked about that last time. See the discussion above for information on how the function arguments are specified. Well, that's interesting. I don't want to know right now. I could, I guess, try to make a function this way. I've never done that. What's a better way to make a function?
Curly braces.
Curly braces, that's right, because it is a literal. It is a thing that we can, well, I guess that's true. It's a thing that we can specify just by stating enclosures. So at the very least, we could just do this, right?
Sure.
All right, and doing this would actually create a synthesis definition. Right, so now there's some synthesis definition. Now, what's kind of odd about this is that it's unusual to assign the synthesis definition to a variable. That's an unusual thing to do. You usually don't do that. It did return a SynthDef. So there is an instance now of SynthDef. But all we really need to do with this SynthDef is to add it. So the last step is to say dot add. And you can just put a semicolon there, or you could say, oh, I'm wondering what that is. Now here I pull up the enclosure and you see there's a big list of stuff. Like, what's the list of stuff? This says that all of these different blueprints, or all of these different objects, sorry, all the different objects take this message add, and it doesn't know which keywords to tell me because it doesn't know which object I'm dealing with. So I'd have to scroll down until I found SynthDef. I'll click it. And then it says, oh, okay, well, what's the library name? What's the completion message? What's keep def true? Like, oh, I don't know. It sounds hard. Semicolon. All right, so then I could add this SynthDef that does nothing to the library. So to make it easy to think about, what happens is that these synthesis definitions get compiled into a binary or something that we can't read, but the server can. That's how the server knows how to make sounds, is it looks at the special format of SynthDef that does not look like this. It's a bunch of zeros and ones, and it's able to generate the sound from that. So anyway, this is boring. It doesn't do anything. So we should make it do something. So let's say that we want to just have a synthesis definition that is a sine wave that goes out and output. Okay. I'm going to make some variables. So anytime you're within a function, right, you can have arguments and variables. I just want to have variables, which are human readable things that really, in many ways, just help me clarify what I'm doing. I'm going to call this sine wave, and that's the only one I need. Notice that after I declared the variable, I put a semicolon because that's the end of my variable statement. These semicolons will trip you up. All right, we have to say what the sign is. And in SuperCollider, a sine wave oscillator is sine osc with a capital S and a capital O. The only things that should be capitalized in SuperCollider are objects like this. So SynthDef, sine osc. Don't capitalize other things. Like, don't even capitalize this, even though it's legal. Just don't do that. Bad form. All right, so with these things that make sound, like sine oscillators, low pass filters, high pass filters, band pass filters, anything that generates a sound signal, an audio signal, we always use the class method .ar. Now, if I were to look at sign-offs and get the help, and I go down here to where the class methods are, it says, well, there's only two. There are no instance methods, although that's not exactly true. But there's no instance methods. It's not exactly true. But here are the class methods: frequency, phase, mul, and add. And it tells me what they are: frequency in hertz, specified at audio rate. Okay. Phase in radians, sampled at audio rate. Oh, sampled, I see. And mul, output will be multiplied by this value. Okay. And add, the value will be added to the output. Well, that's interesting. All right, so I'm going to do the same thing. Put my enclosure up, pop the keywords, go to the next line, hit tab. And now I can say what frequency I want this to be. This particular synthesizer will be very avant-garde and will only play the frequency 555. It will never play any other frequency. And the phase of it, let's say I don't even care what the phase is. I can just skip that keyword. Now you can only skip keywords if you're declaring keywords as I'm doing here, right? If you start writing without the keywords, then that's not going to work. So write with the keywords. The multiplier, what will this do sonically to the sound? Alex, what do you think? What do you think multiplying it by something will do?
Increase the volume.
Increase or decrease the volume. Exactly right. So we want to turn it down. This is about the right level. Negative 20 dB down from full power or 0.1. You have a couple choices here about what to do. Do you put the parenthesis here? Do you go down a line and try to put it there? Up to you. Sometimes I like this because it lines up with this and it looks like one block. Sometimes I'll do this. I don't know. Choice is yours. All right, so there is the sine wave miraculously defined. The last thing to do is to put it out, the output, out.ar. Believe it or not, let's look at the out help file. There it is, says the class methods are AR and KR. This is interesting. So bus says the index of the bus to write to. The lowest numbers are written to the audio hardware. Well, that's what we want. We want it to go out the audio hardware. There are some questions there. Channels array, an array of channels or single output to write out. You cannot change the size of this once the SynthDef has been built. Okay. So it wants to know a bus. Let me just tell you that you put 0 there. That means the first output of your audio interface. Next, we're going to put the channels array. And for right now, the channels array is simply the thing we want to hear, right? And what we want to hear is this sine oscillator. So we just say sine. Why didn't I assign the output to a variable? Well, remember that in a function, well, let's just say that in this special case of the unit generator graph function, the out is just going to output. There's really nothing to be done with that output, so you don't need to assign it to a variable. But you could, it's not going to break anything. So out is equal to out.ar. Same thing. It's pretty obvious that out is out. Okay, so I'm going to now recompile my synthesis definition and add that one to the server. And now the question is, how do I make that make the sound it's supposed to make? A high boot. And the answer is we call synth. So not SynthDef, but synth. And if I look at the help for synth, it tells me a whole bunch of stuff. But I can go here to the class methods and see that there's this new one. Wonder what other class methods? New paused, grain, interesting. Okay, so let's look at new. That's the one we care about. And we put the parenthesis up, and all of a sudden the keywords pop up. I hit return and I hit tab, and I look at the help file. And the def name says a string or symbol. And this time it doesn't tell me what those are, so I have to remember. Specifying the name of the SynthDef to use in the creating the synth. All right, DeAndre, what's the name of this synth that we want to play? What is it? No, it's up there. I made one. I made the SynthDef. Unique, that's right. Yeah. I like that you made up a good name though. All right, unique. All right, and then we've got the rest of this. It says, well, do you have any arguments to your synthesizer? So look at this function. Do I have any arguments to this synthesizer? No, I didn't make any. So I don't even have to go further. I could. Okay, so now this is interesting. I've hit a point, my keywords disappeared. I hit tab, nothing's there. I'm gonna panic. On a Mac, you can hit Command Shift Spacebar, and they will pop back up. All right, so arguments, I don't have any. Target, it says a target for this synth. Let me just say that we're going to get to that later. We're not going to do that. Add action, don't need that. So we're done. All I need is this SynthDef, the synthesis, and I need to say what the name is. And when I do that, I'm going to boot the server here. And when I do that and I hit the shift return, there's my boot. And command period will make that stop. You may want to, switch your audio to your built-in out so you can hear it. You'll have to reboot your server after you do that. But if you click on the little icon up here, you can do that. Then we can all boop out loud. All right, so everybody choose a number within the range of 550 to 560, and we'll make a boop sound that way. Yeah, make sure you're booping out loud. So right here, you got to change it, right? You'd have to change that to 551 or whatever you want to do.
Kill all servers. Boot the server.
Oh, you've got mismatched template. Make sure you're in.
Oh, okay. So if you have this thing where it says your input and output sample rate are mismatched, go to the audio MIDI setup and make sure that your input and your output have the same sample rate. So for you guys, right, the input here would have to be 48K and the output would have to be 48K. And then try rebooting your server. Best to fix that at your operating system level. Go to built-in microphone, Alex. There you go. Make sure it's the same sample rate as your output.
You all are tuned each other.
That's right.
Wait, can we?
It'll be like middle school band or super quiet. So reboot your server, Alex, by going to the bottom right-hand part of your screen and clicking on the green stuff. Yeah, and then reboot the server. And now try making your SynthDef to sound. All right, there's one. I'll turn down a little bit. DeAndre, you're able to make a boop sound? No. Oh, okay, I wish I could pull that up on the screen. All right, so I'm going to 550 and 560. Okay, so we're changing things. I'm going to go up a fifth. All right. Thank you, everybody. So that's an annoying way to have to do it, though, right? To have to change this frequency within the SynthDef, recompile the SynthDef, and then play our synth again. That seems crazy. So let's instead say, like, this is something we want to change, because most synthesizers will allow you to change what the frequency is. Okay, so what I'm going to do is I'm going to make an argument for that. So back up to where this is 555. To make an argument for this function, we have to do it at the beginning of the function. You cannot do the arguments after the variable. You have to do it before. Typically, I put them right here. I don't know why, but that's what I do, right on this line. So the argument will be frequency, semicolon. So we're going to be able to change the frequency, whatever this word is. I made up that word. That could have been pizza or zebra or orangutan or kibosh. I chose frequency. I made up that word because that's what it is. Now, it's not enough to just make the argument, right? It's still going to play 555. I have to put this word right here. This is the thing that will change each time I make the synthesizer. Right, so make an argument here. And then make sure you stick the argument where it's going to make a good change. All right, and then I got to recompile this because it's different. And now if I play this, what am I going to hear? Nothing. Why will I hear nothing? Yeah, it doesn't know what frequency to play now. Okay, well, now I've done it. No, it'll just say, there you go. I got nothing going on. All right, so I'm going to go back here again to my synth, and remember it had this this other thing called args, which implies that there can be more than one argument, which implies that we need an array to specify them. So it says an optional array specifying the initial values for the SynthDefs arguments, controls. These are specified in pairs of control name or index and value. What? So it says it right there, like this, frequency 440 with a backslash. So it says there's two ways to do it, but it's always got to be in pairs. In this case, we're going to just do backslash frequency, comma, what we want the frequency to be. Stop. Okay, so I could have done, though, I could have said 0 here. Because this is the 0 with argument. I'm sorry, I could have done 0 like this. Because this is the 0 with argument. But no one does that. Better to do it like this. You can read it. Like, do this synthesizer with this argument. All right, so now if I run this, I get the thing, right? Cool. You should be able to do that too.
Put all of your arguments in one set of brackets.
That's right. So for instance, if I made another argument here for amplitude, and here I said amplitude instead, here then I would say amplitude and what I want the amplitude to be. So I can just say what the name of the argument is, what's the value? What's the name of the argument? What's the value? Oops. Yes.
So I know typically that we always have like, one or two arguments. Is there ever a case with more than two arguments?
Oh yeah, definitely. Like if I had an envelope in here and I wanted this to have a certain attack time and a certain decay time, well, there's 2 more arguments if I want to do that for every note. If I have a filter and I have, a cutoff frequency and whatever, I mean, that's more arguments. Obviously, working this way is tedious, right? And eventually we get to the point where it's like, well, couldn't we just use a MIDI keyboard to do all of that, right? And welcome to 1984. That's what everybody was thinking. Like, isn't there a way I don't have to type out note lists for everything I want to do? I'm so bored. Right. So realize that this is currently not a quick way to make music, right? There are a lot quicker ways to make the sound we just made. But the point is that we're going to be able to be very flexible in what we do, and we just have to work our way up. All right, so making this sound, makes sound, that's fantastic. I can make more than one of these, right? So synth and then make another one. I'll make this one 557. And we hear the beating tone, the difference tone between these. So every second they're fading in and out because of the difference there. Which implies that I could also do that at 4 hertz. Make these two that far apart. Right, or if I wanted to get really crazy with it, I could start going into in-between zones, a 12 hertz tone. Now it starts sounding like that, sci-fi sounds. All right. So here's the next thing though. I've still got this one synthesizer and it's playing 556. How would I be able to change it so that any of these arguments or these controls, can I change them while the synthesizer is going? And the answer is yes. So I'm going to assign this synthesizer to the letter A. Because if I run the synthesizer, it kind of exists out in server land and it's hard to talk to it anymore. It's like having a litter of puppies and then letting them all outside and none of them having names, just yelling into the void. All right, so A is now equal to this synthesizer. And once I run it, what I can do is I can use the command a.set to set any one of these things here. So I'm going to do 560 after I've run this. So here, well, I'll do something a little different, 660. So I run the synthesizer. And then if I've named it, I can say synthesizer A dot set different frequency. Let's look up the help for set. So here's everything that takes set. Obviously, I want to find synth. It says set ... args, which implies we can do more than one. Notice how you do more than one. Notice that that is not in an array. So unlike how we had to define args here, this defines them just as a list. There we go. I'll run the synthesizer first. And change it. That was wrong. Amp. There we go. Try it again. How you doing over there, Pablo? You still with us? Beautiful.
Yes, yes, I am.
Hybrid classroom. All right, so that's kind of fun. It'd be more fun if I didn't have to click the button so much, but let's get there later. So for example, maybe I want to run this 100 times and have, wait time and all this stuff.
I just have a question.
Yes, sir.
Why the slash, like,
The backslash,
uh-huh.
because this returns a symbol called frequency. So it just wants a symbol. That's the literal type. I think it would also work if we did it in single quotes. Whoops.
Cool.
But that's two typing things you have to do as opposed to one. Another way to do it would, well, I don't know. That's the best way to do it. That's what it wants. That's what it said. Had to do it that way. All right, so let's take one of these examples and let's make a different synthesizer that's a little bit more fun than this. I know it's hard to imagine. Okay, and I'm going to put this here. Let's do number 1 there. I'm going to zoom into this, kick it over.
Turning the sound for me.
Okay, let me look real quick. Looks good. Let's see. So run your synthesizer. You got to run the synthesizer. Oh. Okay, so run your synth def again. Or I'm sorry, evaluate the synthesis definition. think maybe it doesn't have the arguments in there. There we go. Yeah, so you were running the old synthesis definition. It doesn't know what you typed, only what you evaluated. All right, so let me figure out a place to put this. We'll go right there. And this is the one we want to do now. So let's just look at it. It's got out left and out right, a resonant low pass filter, a pulse.ar, and a low frequency triangle. Now we could look and see what this does and try to imagine it in our mind, but let's not do that. Let's just code it up. Like, I don't know what this does. I'm just going to code it. So the way to do that is to first start with SynthDef. So the same thing again, synthDef.new, and name it. Let's name this one 1, comma. And now we have to define the unit generator graph. Well, it doesn't look like this particular one has any arguments necessarily, right? It just looks like a bunch of numbers are plugged in, so we'll do it exactly the way it looks. So the unit generator graph function needs a what to work? What am I putting here? A curly brace, like a function, right? So remember, we can just do the function like this. I'll go ahead and type out the rest of it, right? So if you want to start this way, you can just add an empty synthesis definition and then fill in the graph function. Although normally I would not do that. All right, so what I recommend here is I recommend having variables. So I'm going to make a variable for every one of these unit generators I see. Here I didn't follow my rule. It looks like I used a half moon for the filter. Normally that would be a box, whatever. All right, so I'm going to make a variable for output. I'm just going to make one. Take my word for that right now. And then I'm going to make one for this RLPF. I'll just name it what it is, because maybe I don't know what that is. RLPF, pulse, LF try. So just name variables for everything you see that's in a box. All right, and then we'll just say what they are. So LF try is equal to, and it looks like capital L, F, T, and then a whole help file popped up for me, low frequency triangle. If I hit return, it gave me that thing it thought I was typing. Autocomplete worked. And here it says .kr. Let's do .ar. I changed my mind. So .ar. I do the enclosure bit after that, right? And my keywords pop up. So hit return and tab. And it looks like the frequency, the first thing I do is 1. So just going from left to right, we're going to fill in the keywords. I phase 1. Mul 0.5. Looks like add is 0.5. All right. So you should be able to do that, right? That is just typing what you see. All right, I named this next thing pulse. So I'm going to say pulse is equal to, and then it looks like this object is called pulse.ar. And I put the parenthesis up, and there's my keywords. Tab for the first one, it says 131. And then for the next one, I'm like, oh my God, there's an arrow. And it looks like that LF try we made before is going into what this width is. So how do I put the LF try.kr in here? Yeah, you call it by what you called it, right? So we made a variable for this called LF try. And because we made that variable, we don't have to copy and paste all of this into this thing here, right? We can just call this. This is all of that. So here we put LF try. Questions about that?
How did you know that the width?
I don't, it's just I'm following this thing. It's like, that's the first one, that's the second one. So in this sort of thing, which I made, you know, it's like, well, I just know that because I'm just going in order.
Okay.
So all we gotta do is go in order. If I'm not going in order, I'll specify that, right? Yes, DeAndre.
I don't know if you already said it, but, where did it come from?
So when I hit the comma here, that was just the next keyword,
Oh,
width. And I won't even explain what that is. We'll just listen to it and look at it maybe and see if we figure it out. All right, so there we go. Now on to the next one. We said RLPF, so RLPF, that's what we called this variable. Could have been anything, is equal to a capital RLPF dot AR, so it says. All right, it says, what's my input? And it looks like the input is what? This pulse thing we just defined. So again, we can just use that variable that holds this thing. So this whole thing with all the stuff in it is held in pulse. So just say pulse. And then the frequency is 12,000. And then what's the next thing? RQ, the reciprocal of Q, is 0.5. Okay. Don't even have to know what this does. I just got to put in the words. Now, this is the last tricky part. There's two outputs. So I'm going to put them in this out is equal to, so out was this variable I made up here, equal to out dot AR. All right, now here's where things get a little tricky because it's not as easy as it was before. The bus here is 0, just about always, unless you're doing something very fancy. And the channels array looks like an RLPF and an RLPF. So I'm going to make an array with this square bracket, and I'm going to put RLPF, comma, RLPF. So now one will go out the left, it'll start at 0, and one will go out the right, it'll go to 1. And that's a little tricky, but just believe me for now that that's how that's going to work.
Wait, so is that just basically clarifying like a stereo signal?
That's right. So this is now what goes out the left side is this one. And what goes out the right side, which is really bus number 1, is this one. If I were to have put 16 things there, then I'd have 16 channels of audio going out.
Yeah.
They don't all have to be the same, but in this case they are. All right, so let me close off this thing here. Out.AR. And that concludes this synthesis definition. So now we have the ability to highlight it all and compile it and check out our errors. I got none, maybe you got some. If you got some, they are probably syntax errors. So let me make a syntax error for fun. It's always fun. All right, so now it's gonna break. It's gonna say I'm gonna get an error. It's like blah, vomit on the screen. If I start at the bottom, it's like nil, and then I have command line parse failed. None of that's particularly useful information. Always go to the top of your error. So go to the top of the error, and then it says syntax error, unexpected name in all capitals, expecting a semicolon or a comma. Well, that's a pretty good hint that you missed either a semicolon or a comma. Where did I miss one? And it says line 5, character 7, which is not true. It's always right before where it points to, right? So here it points to LF try. If I look right before that, that's where I'm missing the semicolon. What it read this as was look like this to it, right? Like what is a what? All right, so there we go. We need a semicolon. That was it. All right, so now I'll add this again. You will run into many, many errors. You will learn to debug them.
Dr.
All
Thompson,
right. Yes, Pablo.
I send you to your Discord one error that it shows in my code. Can you check probably?
Let's do this. Can you share your screen? Let me figure out how to do that. Participants. This is the easiest way. Make co-host. All right, Pablo, share your screen if you can.
You can see my screen? Can you see my
It-
screen?
It says it started, but I don't see it yet.
Now.
Not, oh, there it goes. Okay, yeah. So it says command line parse failed, syntax error, unexpected end. Is that what that says?
Yes.
Line 27, character 8 at. Is that a curly brace dot add?
Yes.
It's so you should have a. All right, I got it. So what happened? Let me stop your sharing. I will share my screen and stop yours. What happened is that here you should have a brace like this, right? So what you did is you put add here after the UGen func. We don't want to add the UGen graph func, right? The add method is sent to an instance of SynthDef. So at the end of making the SynthDef, we have to put dot add. Hopefully that will solve it for you.
Can you repeat the last part? I'm sorry.
Sure. So what you've got, if you're looking here, is you've got this, right? And I'll zoom out a little bit. So you can see that this is actually saying dot add to the UGen graph func. And we don't want to add that. We want to add the SynthDef.
Okay.
Yeah.
I think so. So I do not have to. Now I got more confused.
Okay, so
Just to make sure it closes the function.
yeah, you got to close the function for sure. So you know, when I do this, I usually, if I go to this side of the enclosure, it shows me the enclosure that it aligns with. You know, so here it shows me that it goes all the way up to here. That's important, right? So I can look at each one of these. Say, well, where does all this go? Like this one is there, that's right. So make sure you're looking at your enclosures to make sure that they're completed. Going slowly and methodically helps. All right, so this thing is ready to go. I want to make a sound with it. How do I make a sound with it? Allison, how do I do that? Yes, a synth. Yep. I like that. So I'll call this one B.
You would scroll up and check the definition.
One, called it one. There we go.
So one. I don't think you have any arguments, so
No arguments, so I'm
just close it there.
done with that. Excellent. All right, so I will run this and see what it sounds like. I don't know if it's loud or not. I don't see any amplitude control. Well, all right, well, it's loud. I'm gonna turn mine down. How would I turn it down? Could do. Yeah, so why don't we just multiply this whole thing by 0.1? I like that idea. Seems like it's going to be really loud. Yes. All right. There it is. We coded one up. That's what it sounds like. Now I'm not satisfied with that because I wanted immediately to change the frequency, right? So let's review, how do we put in arguments so that I can change the frequency? And maybe I want to change some other stuff too. let's start with the frequency. How do I make an argument for frequency, Josh?
You would go to the Eugen graph function. Type R.
Arg. And then I can call this whatever I want. I will call this fundamental frequency, fun freak. All right, so I put in an argument. It's like, great, you'll be able to pass one in. Will this make it sound any different? Yeah, not until I change something with that, right? So why do I beat that horse dead like that? Because this happens all the time that people put in the argument, but they don't put it anywhere. So you got to put it somewhere. Let's put it there. And for fun, let's give this a default, 131. So now if I don't pass it in, it'll just use this. If I do pass it in, it'll override that.
You can put spaces before and after, you will find it up right here.
It doesn't matter. Okay, so now I'm gonna redo this one. So now it's a new synthesis definition that takes a fundamental frequency. If I don't pass it one, it doesn't break. Still makes 131. But I wanted to change it. So now I put a comma after the name. I got to my next keyword, which was args. And as you will recall, this wants an array of arguments. So here we have fund freak. And I'm going to make this 13.13. There we go. And we'll see what that sounds like. Oh yeah, now it's good. This is like the beginning of a very small rocket ship launching from Earth. It's like made by mice or something. It's got a sparkler on the bottom. Okay, excellent. I could add more arguments. I could change this in numerous ways, right? But I don't want to get stuck here. All right, looking at the rest of these, this is what you should do for practice. I did not make this a requirement to turn in, but here's a similar one to what you have to do. So this one is required from Tuesday. It's not the same one, but there's a similar one. Here's number 3, kind of interesting. You could code this up at home and see what it sounds like to you. Pretty interesting. It's got a delay in there, a sine oscillator whose frequency is modulated by an LF saw, which is modulated by an LF saw. Here's a simple case of vibrato here. Right. So you'll need to practice doing this, right? This is kind of fun. And why is it fun? It's fun because you can make the synthesis definition and then hear what it sounds like. And that's more fun than not hearing what it sounds like. All right, questions. Ask me 2 questions about synthesis definitions. Maybe there are none. Yes, Andrew.
Why is this more flexible than just doing the function? So, why?
Because if I do the function dot play, then I can't do things like make a whole bunch of them at once. Right, so here I'm going to actually make 10 of these go, and they will each have a different fundamental frequency. Right. That kind of organy. So if I tried to do that with a function, then I'd have to stick that function here, and it would start getting ugly. So it's just a way to, there's no difference exactly, except also that when I use the function, I can't actually pass arguments in easily. I can't set the synthesizer easily because it makes its own synthesis definition out of your function, throws it on the server, that makes a synth that's not named. So there's a lot of disadvantages. You can't set things afterwards. And as we move on, we'll see this is the best way to do it. All right, so this is what I wanted to talk about actually is, well, how can we use some of our array knowledge to do more interesting musical things with these synthesizers? So the goal here is how would I make an array and then be able to use that array to determine these arguments, for example. So let's make an array called C. And remember that array has all sorts of really wonderful ways to make arrays. You can make one as a literal just by typing things in, right? So let's do that first. We'll say that I want to have one of these synthesizers that has a fundamental frequency of 131. The next one will have, I don't know, 3092. And then the next one will be 555. All right, so I called that C. Better would probably be to call this like frequencies. Right, but that's more typing. Environment variable, right? So let's review that for a second. What's the difference between a global variable and a local variable? Let me show you a local variable. There's one.
The local variables only work like in the parentheses that they are. I don't know. In the
Yeah,
brackets.
you're right that they only work within this function. Their scope is just within here. And once that's done, it's gone. So if I ask now what's out, it's going to have no idea what that is. It threw it away already. It's like, I don't know, but it's right there. You're like, yeah, but that was a long time ago. I have no short-term memory, so that's gone. Whereas if I define frequencies, right, and it's not even in a function, it remembers what that is even after the fact, right? It has good short-term memory. It has great long-term memory. As long as you don't quit the program or recompile the library or restart the interpreter, it's going to remember what that is forever and ever. The same with C. All right, or global variables, which are A through Z. All right, so I'm going to store this in something called frequencies because that's a better name for it. And now what I want to do is I want to go through this array and I want to make a synthesizer with each one of these things. Oh, interesting, right? There's a few ways to do this. I'll do it the way I would normally do it, which would be to say frequencies, which remember is this array 131, 392, and 555. Dot do. And it wants a function to do. So this is the way this looks. Let's do it without any sound first. So frequencies.do will do something with each item in the array. How do we get at each item in the array? Well, by magic, that's what's passed in. Right? So what's passed in is actually two things. I made up these words. It could have been anything, but I called them what I think they are, which is each item, 131, 392, and 555, and each index, which remember is the place of the item in the list. So 0, 1, 2, which is like counting. All right, so each item is each item. And so if I just print it out, then we'll see that it prints out each item. 131, 392, and 555. Well, I don't actually want to just print it out. I want to hear something. So I'm going to take this synthesizer, just put it in here. All right, so now format it so it looks reasonable. So now what it's going to do is it's going to play this synthesizer 3 times as fast as computers can do things. Right, so I haven't used each item or each index. All it's going to do is it can make 3 of these with the same frequency. So let's do it. There we go. So we have 3 of these things. Obviously, I don't want 3 with the same frequency. I would rather have 3 with one with a frequency of 131, one with a frequency of 392, and one with a frequency of 555. How do I do that? Well, let's review again. I'll back up here.
That's the duration in time, right? What's the duration between?
No, it's just going to do it as fast as possible. We're not dealing with time yet. There we go. So right now it's doing what should I replace 131.13 with? Maybe squiggly frequencies, but remember that I'm actually iterating through this array and I'm getting each item from that. If I put in squiggly frequencies there, it's going to try to pass all three of these things. Yeah, each item. That's the stuff. Okay.
That's the stuff.
Each item. All right. So now if I do it, wonderful. I might have to change this one. Let's go to 392 times 2. All right. That was a little too disconcerting for this time of day. Oh yeah, so it's like, you know, the 1970s and some space movie and there's a hero. Yeah. Awesome. Okay, well let's add to our frequencies, right? Let's make more of them. How about 392 times 2 times 1.1? Hey. I'm just making up numbers. I should just put like 1,000. There we go. All right. Yeah. Now I can make chords, right? Well, let's make chords in a more natural way. What if I wanted to make a C major 7 chord? How do I do that?
Start with the C, which is the MIDI note 60.
All right, let's talk MIDI. Yeah, let's do MIDI. All right, so C is 60, E is 64, G is 67, and B is 71. A major 7 chord.
We're going to convert that to frequency.
Right, because what's going to happen if I play this right now? What's it going to sound like?
Low frequency.
A lot, these low frequencies. So it doesn't, we'll play it to hear what that sounds like. Well, that's not a C major 7 chord. So what do I have to do here to each item? Dot MIDI CPS, right? So we learned that before, that this is one of the superpowers of simple number, is that it's able to convert something like 60 to the cycles per second. So if I do that, then I should get major chord. Nice. I mean, I'm hearing things right now and I keep wanting to change them. Like, I don't really like the way this is being modulated. But anyway.
Could you put MIDI CPS after the array?
You could. So let's say dot MIDI CPS, and then we'll see what it returns. It returns the proper frequencies, but I would have to get rid of it here now.
Yeah.
All right.
Or there'd be some crazy MIDI notes.
How would I make this a C major 7 with a ninth?
That's another cue.
What's a ninth in this world of MIDI? 74. Because 60 plus 12 is 72, that'd be the octave. So now we're up on a D, right? Let's keep going. Hey, why not? How about 77? $78. Get up to F sharp. Sweet. How would I add an octave, like a low grounding frequency to this? That's a C below this. Could be 48 or 36, right? Nice.
That's pulsing because of the
Yeah, because of this. Well, because it's going to 0 for one. So I'm going to change some things. Don't bother. I'm going to do this. I'm actually going to slow down the rate of modulation here. I could make arguments for all of this, but I'm just doing it in this ugly way. All right, it's my frequencies, and then Cool. Yeah, I think that's enough for today. This gets to some interesting stuff, right? Maybe I want to on every iteration through this, you know, like add a random amount of detuning to each of these. So I'm going to do that. So what's a bit detuned from 60 would be like 60.1, right? It'd be like a tenth of a semitone higher than it's supposed to be. So I'm going to say each item plus 0.1 dot random. So up to a tenth of a semitone off.
Did that rank that from 0 to that number?
That's right.
Random?
There's another way to do one, which is each item. That's right, R rand. Yeah, so we could say between some number and some other number. Range rand. All right, so this is this, right? But this is going to give me these numbers. So I have to now take this whole thing. It's getting kind of ugly. You know, maybe at this point I should make a variable and store it, but I'm not going to. I should. I'll make a variable called pitch, and pitch is equal to all this crap. That. And then here I can say pitch.midi CPS. So this will give me 36 times, whoops, that's not right. So plus some amount. Maybe I should go from negative 0.1. So plus or minus some amount and then make it sound. So let's hear what it sounds like, because that's always the fun part. Let's make it more extreme. So as much as a quarter tone off. Unpleasant. Disturbing.
Interstellar car horn.
Interstellar car horn. Yeah, I think I had it right at 0.1. It's pretty good. All right. Well, this is the fun part, right? You make sounds. And I'm kind of wanting this. I'm kind of wanting this really low sound too. All right. So that's that. What you have to do today or this before Tuesday, you have to look back. Make sure you're logging into Folio and looking at all this stuff. I mean, I do put stuff up there. I'd hate to think no one looks. So remember that this was from Tuesday, that you have to do this modulation flow chart. And there's this checklist which says, watch this tutorial. So if you haven't watched any of those yet, watch all the way up to number 5. Using the flow chart that was handed out, I didn't hand it to you. Turn it in via Dropbox. And here's the things you should know how to do, right, theoretically. For today, there is the following stuff, which is here in the checklist. It says catch up, right? Watch number 5, watch that, and then catch up on it, and catch up on the reading. Catch up. All right, and again, if you have any questions, you run into any stumbling blocks where you're like, I really don't want to, I don't want to beat my head against this wall much more. I'm getting tired of it. Then Discord, email, either of those works, and I will get back to you and help you out with some of these easy struggles, generally syntax errors and things like that. Stop the recording. Hey, it was good seeing you, Pablo. Even though we don't see you.
Same. I mean, yeah. This.
Hope you're having a good time in Chicago. Is it cold?
It's cold. It's cold. It's horrible.